Okay, let's move on to see different ways we can use this. We're dealing with permutations here, and let's do another example. Let's say that we have 8 teams, and we're at the bisac turn. Okay, there's how many different ways can we finish from first to 8th? So we have 8 teams, and how many different kinds of order could I put 8 different teams? Well, can you guess? If we have 8 teams, 8 different choices, 8 times 7 times 6 times 4. All right, it's 8 factorial. Okay, but how could I do it if we have a different situation? This is the new way. What if we have only first to third place to be considered? So what if I wanted to know the different possibilities that 8 teams could place in just first to third place? So we have 8 different teams, and I want to only choose 3 teams out of those 8, but how many different combinations of those 8 teams could be in those 3 places? Okay, well, the first spot would be 8 teams for first, but then we've used 1 team, so the next choice would be only 7 people for second place, and then third place would end up being 6. Okay, so we end up getting 336 different teams. Okay, but let's develop a formula here that we like to call a permutation. Let's say I have the 8 teams, and I have a permutation, and I choose 3. We read this 8 choose 3. Okay, or we take 8 different choices 3 at a time. Okay, so that really means 8 factorial divided by 8 minus 3 factorial. Alright, and let's do this out. This is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by, well, 8 minus 3 is 5 factorial. 5 times 4 times 3 times 2 times 1. Do you see what ends up happening? Slash, 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 Fruit Ninja Slasher, and the 2's and the 1's cancel, and we really just get 8 times 7 times 6. So this ends up equaling 336 as well. So what is the mother equation that we can find for this? Well, if we have some type of number, and then we're choosing another number, r, let's say, well, it's that number factorial divided by n minus r factorial. Okay, let's have another situation. Let's say that Mr. West, okay, is a rapper. Well, he's already a rapper, but if he was really a rapper, he would have made songs by now, and he would make 12 songs. Okay, and let's say that he wanted to make a CD, and he only wanted to have 4 songs in his CD. He's not sure which ones to pick. How many different options could be on the CD? The order of the songs matter. So what is the first song, the second song, the third song, the fourth song? He cares about those things. All right, can you guess what it is? Okay, well, we'd have 12 songs, choose 4. Okay, that would end up being 12 factorial divided by 12 minus 4 factorial, which ends up being 12 factorial divided by 8 factorial, which ends up equaling, well, if I do this in my calculator, let's just bam it out, 11,880. Okay? Okay, let's deal with some different types of permutations. Let's look at word permutation, okay, with repeated events. Okay, let's check out this word Miami. All right, how many different ways can I rearrange the letters in the word Miami? How many different ways could I rearrange this word? Put the M over there, put the M over there. How could I rearrange it? Well, you think we have 1, 2, 3, 4, 5 different letters, so it's going to be 5 factorial. But what you have to pay attention to is that I is repeated twice, and that's a 2 factorial. So we need to divide by 2 factorial because we have 2 letters that are repeated, and we end up getting 60 here. Alright, another one we could do is the word Tallahassee. Okay, how many ways can I rearrange the letters in word Tallahassee? Well, how many letters are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 letters, so it's going to be 10 factorial, but no, be careful. We have A is repeated 3 different times, that's 3 factorial. We have 2 repeated, that's 2 factorial. And the L is repeated twice, that's 2 factorial. So I must divide, just like I did up here, by 3 factorial, 2 factorial, and 2 factorial. And I end up getting 151,002. Okay? Okay, let's dive into a whole nother realm of combinations. Okay, combinations is when order does not matter. That means I don't need to know where things go in first place, second place, or third place. People do not have different positions. We just have them. There's no more slots to put choices in. We just grab the kids and then they stay there. Let's jump into an example. Let's say that we have 10 people. Okay, and they want to be on a chess team. All right, but the coach, okay, can only choose 3 players out of the 10 people. Okay, so how many different combinations do we have? Remember, order does not matter. Okay, so I'm going to have less choices because I don't have to have the 3 kids and then put them in order too. I can have the 3 kids in any order I want. We end up using combinations, and we'll have some number C of R. Alright, just like we did before, but now we're using combinations, and we'll have n factorial divided by n minus r factorial. Now I'm going to add in an r factorial there. So in our example here with 10 people, I'm going to have 10C, and I'm going to choose 3 players only. Okay, and that's going to equal 10 factorial divided by 10 minus 3 factorial 3 factorial. I plug this into my calculator and I end up getting 120 different choices of these 3 kids. It doesn't matter what order they're in. There's only 120 different teams of 3 players I can grab from 10 players. Let's say that we're talking about 52 cards in a deck. You know, playing poker. You guys ever play poker with a deck of 52 cards? Well, how many different combinations can I have of 5 cards? You give me 5 cards, I have 5 cards. It doesn't matter what order they're in, I just have 5 cards. How many different types of 5 cards could I have? Well, let's decide what we have. We have 52 cards, and we're going to choose 5. So in our little formula, we're going to say 52 factorial divided by 52 minus 5 factorial times 5. We add that times 5 in because order does not matter. We're going to have less choices because we don't have to put things in order afterwards. And we end up getting a total of 2,598,960 choices for 5 different cards. Think you can memorize all those and be good at poker? I don't know. That's a lot of different choices. Okay, let's jump into our final realm of combinations. Okay, this is when we have event A and event B happening. Okay, these are different events. The important words here are going to be in word problems. If we have the word and or. Okay, and let's say that we still have our 52 playing cards. Okay, and let's define event A. Event A will end up equaling, let's say it's I want all the same color card. All the same color. We have black or red. Alright, so that means there's 2 choices, black or red. Choose 1, which ends up equaling 2. Let's say event B is choosing 5 cards. Well, because we only have 1 color, we're going to have, so let's say choose 5 cards. We only have 1 color, so out of the 52, that's half of them. We have 26 choices, okay, and we're choosing 5. This combination is going to end up being 65,560. What's important is I want to say event A and event B happening? What's the chance of event A and event B happening at the same time? That we have all the same color, and we also have 5 cards only. So I will multiply these two. 2 times 65,560 ends up equaling 131,560. Okay, let's jump into one more. We just dealt with and let's deal with or. Okay, if we have event A happening or event B happening. Okay, let's say that I want to have 2 face cards. Okay, that's like jacks and queens and kings. Okay, and event B is the same thing as we had before. Let's only one color. Okay, so we've already decided if we only want one color, that's going to be 2, choose 1. Okay, because I have 2 colors, and I've got to have one color that I'm choosing for. Now, if I have 2 face cards, I have a total of 12 face cards, but I'm only going to have one color, so I only have 6 face cards. So if I only have 6 face cards, then I'm going to choose 2, okay, which ends up equaling 15, okay, and this ends up equaling 2. But instead of multiplying with or, we add. So I'm going to say 15 plus 2 equals 17 different combinations that event A or event B is going to occur. Okay, thanks for listening. Have an awesome day. Woohoo!